What could you do with $57 billion? With that kind of cash, Elon Musk didn't just buy a seat at the table. He bought the entire table at Twitter and still had a mountain of change left over to launch rockets into orbit. If social media isn't your thing, you could have built nearly 40 Burj Khalifas, the tallest building on the planet, and still had enough to landscape the desert. Or, if you're looking for the ultimate way to burn through a fortune, you could pour every cent of it into a massive, muddy hole on the coast of Somerset, England. That is Hinkley Point C, and it is officially becoming the most expensive nuclear power plant ever constructed in human history. Spanning 430 acres of the British coastline, Hinkley Point C is currently the largest construction site in Europe. It was sold to the public as the dawn of a new atomic age for the UK, promised to power 6 million homes and provide 7% of the nation's electricity for the next 60 years. But for a country that hasn't built a reactor since the 1980s, this renaissance has quickly devolved into a financial nightmare. The sticker shock is enough to give any Wall Street analyst a heart attack. Back in 2016, when the ink was drying on the contracts, the price tag was a steep, yet seemingly manageable £18 billion. Fast forward through a decade of delays, regulatory chaos, and a global pandemic, and that figure has ballooned to a staggering £46 billion, or over $57 billion in US dollars. To put that in perspective for Americans, that is significantly higher than the total spent on the new reactors at Plant Vogtle in Georgia, which itself was a notorious poster child for nuclear budget overruns. We aren't just looking at a power plant anymore. We are looking at a spectacular feat of engineering that is increasingly at risk of being remembered as the world's most expensive cautionary tale. To understand how the UK ended up in this $57 billion sinkhole, we have to travel back to 2016, a year that, in the fast-moving world of global energy, feels like an ancient era. Back then, the British government stood before the cameras and signed off on what was hailed as the deal of the century. A contract to build a state-of-the-art nuclear facility for a mere £18 billion. It was a move designed to prove that a post-Brexit Britain could still handle the heavy lifting of industrial megaprojects. The timeline was equally ambitious, with a grand opening scheduled for 2025. In the world of infrastructure, that is the equivalent of a limited-time offer that sounds too good to pass up. But as any American homeowner who has ever hired a budget contractor for a kitchen remodel knows, the initial quote is rarely the final bill. This wasn't just a simple purchase. It was a high-stakes partnership with EDF, a company essentially owned by the French government. For the UK, it was a classic bait-and-switch, though perhaps not an intentional one. They bought into a vision of clean, affordable, and reliable power, only to find themselves trapped in a contract where the goalposts weren't just moving, they were being airlifted to another continent. By the time the first real shovels hit the ground, the £18 billion figure was already starting to look like a polite fiction. The 2025 completion date? That's now a distant memory in the rearview mirror. Current projections suggest the first reactor won't even be operational until at least 2029, with full power not expected until 2031. The commentary from analysts today is scathing. What was sold as a strategic masterstroke has morphed into a costly joke, a lowball bid that turned into a gold-plated invoice. In the high-stakes world of nuclear finance, 2016 wasn't the start of a renaissance. It was the moment the UK walked into a financial trap. They traded long-term energy security for a price tag that was fundamentally disconnected from the reality of building a first-of-its-kind reactor in a country that had forgotten how to do it. It is a brutal reminder that in the nuclear industry, on time and on budget isn't just a goal. It's a miracle that rarely happens. If you want to kill a project of this magnitude, you don't need a wrecking ball. You just need a pen and a very long list of regulations. In the world of nuclear engineering, Hinkley Point C is suffering from what we might call death by 7,000 cuts. C. The original plan was to use a proven blueprint already deployed at sites in France and Finland, the European Pressurized Reactor, or EPR. Logically, you'd think the engineers could just translate the manual and start pouring. But British regulators didn't see it that way. They demanded a staggering 7,000 design alterations before a single reactor could be deemed compliant with UK standards. We're not talking about moving a few light switches here. These were fundamental structural changes to the core of the facility. Because of these constant tweaks, Hinkley Point C has swallowed 25% more concrete than its French and Finnish predecessors. To give you an idea of the volume, the team poured 9,000 cubic meters of concrete in one go for the base of the first reactor, obliterating the record previously held by London's iconic Shard skyscraper. Then there's the steel. 35% more of it was crammed into the build to satisfy those hyper-stringent British safety codes. For the American viewer, this looks like the ultimate red tape horror story. It's bureaucracy on a scale that makes a state-level infrastructure project look like a walk in the park. But there's a deeper, more painful reality underneath the paperwork. Because the UK hasn't built a plant like this in a generation, they weren't just building a reactor. They were building an entire supply chain and a specialized workforce from scratch. Every time a regulator changed a spec, it rippled through a system that was already struggling to find its footing. EDF identifies these 7,000 changes as a primary culprit for the project's massive delays and hemorrhaging cash. It creates a brutal engineering paradox. In the quest to make the plant perfectly safe on paper, they've made it financially impossible in reality. The massive steel pressure vessel, the heart of the machine, finally made it inside the reactor building in late 2024, but only after years of design and manufacturing hurdles. At this point, Hinkley Point C isn't just a construction site. It's a $57 billion battlefield where safety standards are constantly at war with the laws of economics. The biggest mystery in this $57 billion saga isn't just the price tag, it's the checkbook. Why is the French government, through its state-owned energy giant EDF, essentially bailing out the British energy grid? Imagine a high-stakes poker game where one player is losing billions but refuses to fold because their entire reputation is on the table. That is Paris right now. EDF is now fully owned by the French government, and they are the ones firmly in charge of Hinkley Point C. As the costs have spiraled toward that jaw-dropping $57 billion mark, it is the French who are left holding the bag for the construction overruns. This isn't just about providing electricity. It is a desperate, multi-billion-dollar gamble to keep a national industry from going extinct. The technology being used here, the European Pressurized Reactor, or EPR, is France's flagship nuclear export. Yet it has been plagued by catastrophic delays and budget busts at sites in Flamanville and Finland. If Hinkley Point C fails, the EPR brand is effectively dead on arrival for the global market. For Paris, this project is a must-win at any cost. They are playing the long game, betting that by eating these massive losses now, they can finally stabilize the technology and perfect the process for Sizewell C, the virtual replica they plan to build next in Suffolk. It is a geopolitical irony that would make a novelist blush. Britain, the birthplace of the Industrial Revolution, has effectively outsourced its critical energy infrastructure to its oldest rival across the Channel. For the American observer, there is a familiar scent of too big to fail hanging over the Somerset coast. The French are doubled down, hoping that the efficiency gains they are finally starting to see, like welding the massive steel pools 4 times faster on the second reactor than they did on the first, will eventually turn this financial nightmare into a sustainable model for the future. But make no mistake, the French connection is a marriage of necessity, not love. EDF has been hit by a perfect storm of labor shortages, material price hikes, and a year of COVID-19 delays, all while trying to navigate those 7,000 regulatory changes that turned the initial budget into Swiss cheese. Paris cannot walk away because they have already buried billions in the Somerset mud, and London cannot fire them because there is no one else in the Western world with the blueprint to finish the job. They are locked in a financial embrace, drowning in a sea of red ink, and hoping that the next generation of reactors will somehow justify the absolute carnage of the current one. If you can look past the bleeding balance sheets for a moment, the physical reality of Hinkley Point C is nothing short of breathtaking. This 430-acre expanse isn't just a construction site. It's an industrial cathedral built from an almost unfathomable amount of steel, concrete, and sheer human will. Dominating the Somerset skyline is a machine that sounds like it belongs in a blockbuster movie, Big Carl. As the world's largest land-based crane, this mechanical titan has been the MVP of the project, hoisting massive reactor domes and liner rings weighing hundreds of tons into place with the kind of precision you'd expect from a watchmaker, only on a godlike scale. Each of the 2 reactor units requires 3 of these giant rings to form the inner containment wall, which is then encased in 2 thick layers of reinforced concrete. The sheer mass of the materials involved is enough to make any American civil engineer's jaw drop. To set the foundation for the first reactor, crews performed a continuous pour of 9,000 cubic meters of concrete, shattering the record previously held by London's iconic Shard skyscraper. But this record-breaking wasn't exactly a choice. It was a necessity. To satisfy those 7,000 regulatory changes we discussed, the project has had to swallow 25% more concrete and 35% more steel than the European plants it was originally modeled after. We are talking about structures built to withstand everything from catastrophic floods to earthquakes, safety margins that are virtually unprecedented. Even if the UK isn't exactly a high-risk seismic zone, deep inside these reinforced fortresses sits the heart of the beast, the giant steel pressure vessel, which was delivered in 2023 and eased into position in late 2024. Surrounding it are 4 steam generators, each 25 meters long and weighing over 500 tons, monsters that required 6 years of meticulous design and manufacturing in France before crossing the sea to their new home. Just next door, the turbine halls stand 50 meters tall, designed to house the largest power-generating turbines on the planet. It is a spectacular feat of engineering, a testament to what we can build when money is no object. But that's the rub. In this story, the brilliance of the machine is constantly being eclipsed by the darkness of the financial black hole that is the project's budget. The metal giants are rising, but the financial ground beneath them continues to shift. But the costs of Hinkley Point C aren't just measured in piles of cash and massive slabs of concrete. There is a hidden human and environmental tax that is pushing the project even further into the red. You can't just buy a nuclear workforce off the shelf. And because the UK hasn't built a reactor in a generation, EDF has had to spend years and millions training a specialized workforce from scratch and rebuilding a fractured supply chain. These labor and material shortages, compounded by over a year of delays caused by the global pandemic, have turned the construction timeline into a moving target. It is a brutal lesson in industrial atrophy. When you stop building big things, you forget how to do it, and relearning that lesson is incredibly expensive. Then there is the environmental PR disaster that most Americans wouldn't expect. While everyone worries about nuclear waste, which the UK plans to eventually store hundreds of meters underground in a specialized facility, the real battle on the Somerset coast is actually about fish. To keep its reactors cool, Hinkley Point C needs to draw in up to 120,000 liters of water every single second through 8 kilometers of tunnels connected to the Bristol Channel. This creates a massive underwater vacuum that threatens to suck in and destroy tons of local marine life. To mitigate this, EDF is proposing a fish recovery system, but they are locked in a fierce dispute with regulators over a requirement to install an acoustic deterrent, essentially a massive underwater sound system designed to blast noise and scare fish away from the intakes. EDF has pushed back, calling the acoustic technology dangerous to install and unproven. Their proposed alternative? Flooding hundreds of acres of Somerset farmland to create new salt marshes as a compensatory habitat for wildlife. But this green solution has sparked a new firestorm of controversy, with local farmers and the council objecting to the loss of productive land. This environmental tug-of-war is more than just a local dispute. It represents the hidden tax of modern megaprojects, where the cost of satisfying every stakeholder and regulatory body can be just as high as the cost of the reactor itself. Every month this debate drags on is another month of overhead, another month of interest, and another layer of complexity added to the $57 billion nightmare. Ultimately, we are left with a staggering paradox. Hinkley Point C is either the most visionary energy project of the century or the most expensive light bulb in human history. By the time the first reactor finally begins huming in 2029 and full power is achieved in 2031, the UK will have spent over $57 billion to secure just 7% of its national grid. For any American observer, the math seems almost impossible to justify. Yet, in the cold, hard reality of global energy security, the UK has backed itself into a corner where it simply cannot afford to fail. There is, however, a glimmer of hope buried beneath the mounds of Somerset mud and red ink. The nightmare of the first reactor has served as a brutal $57 billion classroom. Engineers are already applying the hard-won lessons from Unit 1 to make the construction of Unit 2 roughly 20% to 30% more efficient. They are welding massive steel structures 4 times faster than before, finally finding the rhythm that was lost during those decades of nuclear stagnation. This isn't just about one plant anymore. It's about the pipeline. The UK is currently planning to quadruple its nuclear capacity by 2050, and the next project, Sizewell C, is intended to be a virtual replica of Hinkley. The goal is simple. Avoid making the same $57 billion mistake twice. As we look at this spectacular feat of engineering at risk of being overshadowed by controversy, we have to ask what success actually looks like. If Hinkley Point C provides reliable, low-carbon power for the next 60 years, perhaps the astronomical price tag will be forgotten by future generations who only care that the lights stayed on. But if the delays continue and the costs keep spiraling, it could become a monument to industrial inefficiency that scares private investment away from nuclear power for a century. The UK's journey to regain ground on an epic scale has been difficult, chaotic, and eye-wateringly expensive. Whether this $57 billion nightmare is remembered as a stroke of genius or a cautionary tale remains to be seen. But one thing is certain: the eyes of the world are on Somerset. In the high-stakes game of the global energy transition, Hinkley Point C is the ultimate all-in bet, and for the sake of the British taxpayer, we'd better hope the house doesn't win.